It's a fully indigenously built processor. So we tested as a piggyback experiment yesterday, and results have been extremely good and it has performed very well. So continuously we are trying to improve the capability of the polar satellite launch vehicle, and in addition to that, the geostationary satellite launch vehicle, which makes use of what is called a cryogenic technology. Now this cryogenic technology is making use of liquid oxygen and liquid hydrogen as fuel, and then realizing an engine which can give heavy thrust, and then putting satellites into geostationary transfer orbit. Geostationary transfer orbit means, like earlier I said, geostationary satellites are all at 36,000 kilometers. These launch vehicles put the satellites into an elliptical orbit between 250 to 280 kilometers perigee, and between 22 to 36,000 apogee. They put the satellites into orbit, and then the satellite makes the necessary corrections to circularize it. So this geostationary satellite launch vehicle also, initially we started the work in collaboration with Russians. Very soon the geopolitical forces made sure that this event is not going to happen, and it was getting converted into only a procurement, and about 6 engines were procured from Russians. And then we started our own indigenous cryogenic technology development, and this year we did the 3rd consecutively successful indigenous cryo engine based GSLV Mark II, and in that we also launched a meteorological satellite INSAT 3D. The cost of launching such a satellite just 2 years back, which we did, compared to that, in this launch, both the launch vehicle cost as well as the satellite cost is less than what we would have paid to the international agency for launching such a satellite. So this is again a fully indigenous development, and now we are also working on a capability of increasing the satellite from 2.2 tons to 4 tons. Here again it's a new cryogenic engine. We have gone through the qualification tests of 2 independent hardware. Just recently we completed a 25-second test on the flight hardware. Now the satellite launch vehicle is getting assembled in Sriharikota, and we expect by January next year GSLV Mark III, which will carry communication satellites of about 3.2 to 3.3 tons to start with, and ultimately reach 4 tons. This is going to be done next year. So progressively the launch vehicle technology we are building and increasing our ability, and you can visualize a launch vehicle technology has a large number of propulsion elements and different technological elements which are involved. All this is realized through the Indian industry. We spend more than 80% of the fund on the launch vehicle technology, actually realizing the hardware through the Indian industry. And this Indian industry also is actually handheld and then ensured they succeed in their effort to bring up these parts. So this is one of the very significant capacity building we have been able to do in the country. And today we have completed, like I said, 37 PSLV launches, and the GSLV Mark II and Mark III we are going to do very shortly. Similarly, in terms of satellite technology, apart from the meteorological satellite, which I said in the initial years we started with INSAT 2 series, where you could get the image of Earth based on that cloud cover and cloud motion vector determination, using it in our weather models. The capability was 2 to 3 images or 4 images per day. Today we are able to generate 96 images per day every 15 minutes, and using that you are able to generate the atmospheric motion vectors, vertical temperature and humidity profile, and this information is going into the numerical weather modeling of India Meteorology Department and also NCMRWF at Delhi, and they are using this data for improving the short-term forecast. And of course there is still a very significant effort required for improving the medium-term and long-term forecast, because here it is not only the satellite data that is needed, but also a large number of in-situ data from ground requires to be collected, whether it is rainfall rate, or in terms of temperature and various other measurements, including Doppler weather radar, wind profiler, etc. Even in these areas, ISRO has been developing capability, automatic weather stations, and then transferring that data to India Meteorology Department so that weather predictions of future can improve. We have also built satellites which are capable of making Earth observation. Like I said, you are able to do cloud cover images. You are also able to take images of the Earth and images of the ocean. Using the ocean color, you are able to actually tell where the fishermen can go for fishing. So this is a service which has been started from 1999. Today there is an entity in Hyderabad called Indian National Center for Ocean Information System, which provides to the fisherman exact location where he can go for fishing. This information is also generated based on the Earth observation carried out by the ocean color instrument and also the thermal fronts which are generated by the instruments carried on the satellites. And today, from 99 onwards, this information is going to the fishermen, and this alone saves to the country between 15 to 20,000 crores a year in terms of fuel saved, because the fisherman, when he has to go to a place where when he starts, if he is not aware where he is going to get the catch, he has to do searching and spend lot more time, and still he is not certain at the end of that whether he will get. So this is another major thing that has happened. And again, based on the satellite data, the kind of services that were provided is groundwater, actually borewell drilling. More than about 4.5 lakh borewells have been drilled over last 3 decades using the information generated from the satellite. And the success rate of these borewell drilling has been between 90 to 95%. And today we are in a position to provide to the government a series of host of information generated from Earth observation satellites, like the one we launched yesterday, the ResourceSat 2A. It has got a very unique capability. It can provide images of the Earth in 3 distinct resolutions, starting from 50 meters. Every 5 days we can cover the entire country at this resolution. It has a swath of about 740 kilometers, and this allows the observation of the vegetation on the surface of Earth. Using this, crop phenology and crop production forecasting estimations are possible. We also have in the same satellite a resolution at around 20 meters and 5 meters, and all these 3 together gives a unique capability. And today in Delhi there is an entity called Mahalanobis Crop Forecasting Center, National Crop Forecasting Center, which actually makes use of the technology developed by ISRO and demonstrated over a period of almost 3 decades. For about 11 crop types, what is the likely harvest or yield that we are going to get ahead of harvesting, 1 month ahead, 2 months ahead, or even 3 months ahead. This information is generated and it is made available. It is there for wheat, rice, sugarcane, groundnut, cotton, gore, like that, many of these types it's able to do. Now today we have about 39 satellites in operation in space. Out of that, a number of them are communication satellites. Communication satellites are able to give connectivity not only for DTH services but for small aperture terminals, VSATs, what is called, for ATMs and a host of other communication networks, telephone network, and also for transferring information from one location to another location. Then beyond that, we also have a navigation satellite series. You are aware that while the world, Americans and Russians or even Europeans are going in for a global positioning satellite system, which requires between 28 to 32 satellite constellation for providing information about using ground receivers where you are in terms of latitude, longitude. Our own constellation is only a 7 satellite constellation. This is again one of the innovations that are done. Of course, this does not give us global coverage, but it gives us India and surrounding India, minimum about 1500 kilometers around our borders. The entire area we are able to cover with a constellation of only 7 satellites, and these satellites also operate in geostationary locations, unlike the elliptical orbits of GPS series. And again, yesterday in our launch vehicle, using this IRNSS constellation, we had a ground receiver which determined the position of the launch vehicle from the liftoff till it put the satellite into orbit. So we have demonstrated that Navik receiver, a receiver which makes use of our own Navik constellation, is able to provide necessary information for navigation of satellites. And this constellation has been made fully operational, and it is going to be used for a large number of applications. Like I was talking to you about the fisherman. The fisherman will carry with a small gadget, he will be able to know where he is and where he has to go, that message he will receive. In addition to that, he will also be warned of international boundaries, so that he need not transgress or go across the international boundaries. And many times you would have been reading in the paper, some German is arrested because he has crossed over the international boundaries, etc. So many such applications are possible. Beyond that also, in terms of transport sector, very interesting applications are possible. Just the other day we came across one of the entrepreneurs in Mangalore who is making use of positioning information. What he has done is, in a auto rickshaw, he has fitted a positioning system, and then locally he is transmitting that information to a common location. Now, depending on what route the rickshaw flies, which commercial area, how long it has been on the road, that rickshaw gets a T equivalent of a TRP rating. And on the basis of that rating, he gets paid monthly, because he is carrying on his rickshaw an advertisement board. Now the agency which is providing this service is able to make use of money from the advertiser. Advertiser also is very happy because he knows for certain that this board is not lying at one place, but it is actually flying around and it is in some commercial areas. So he is able to, so like this, there were a large number of very different applications which is only limited by the imagination of the entrepreneurs is happening. So navigation information, so we, like I was telling, so we are able to actually make use of all the technology that is accessible to us, and those technologies which are not accessible, we are indigenously realizing. And in this process, we have also made sure that a large number of spin-off technologies have come up. For example, you would have read that polyurethane food, and also, for example, there is going to be a very lightweight, highly insulating material which can be used in very cold times, then fire resistant paints, and a host of other things which are available. And the capacity building in the country, while we do all these space technology activities, one of the key things is in the area of science and technology. Science, for example, when we did our first lunar mission, all of you are aware, man had already landed on the moon, and there were large number of probes which had gone around the moon. But still, it is Chandrayaan-1 which gets the credit for discovering water molecules and also the process by which such molecules, OH molecules form. Actually, the credit goes to Chandrayaan-1. So what this also shows is, in science and technology areas, it is never too late. There is always something new to discover. There is always something new that can be done. We should never lose heart, because today we do not have access to some advanced technologies. Only through advanced technologies things are going to happen is not the right approach to take. There is always something new to learn, something new to make it happen. So like this, in Chandrayaan-1, it was also an excellent example of how international cooperation can be fostered and new things can be achieved. In the same way, the Mars mission, when we did the Mars mission, the success rate of Mars missions, almost 53 missions have been done, only about 22 or 23 had succeeded. But when we went ahead and completed this, we were the first to, in our maiden attempt, to achieve the insertion of a satellite into the Mars orbit. Now just to visualize what is the kind of complexity that is involved in this, suppose you are told on the 5th of November 2013, when we are putting this satellite into orbit, on the 24th of September 2014, 7:30 a.m. in the morning, to that second, after traveling more than 650 million kilometers or 65 crore kilometers, this object has to be in a cube of 50 kilometers. You imagine a cube of 50 kilometers, and within that cube, it has to be there on after tens of months of travel. That is the kind of complexity that was there from launch till you reach that point. The initial launch has to be successful. You have to do a lot of maneuvers, and then you have to make sure that while you are doing all these 650 million kilometers of travel, the forces that are acting on the satellite which can disturb. For example, if you are told that when the satellite travels for months like this, even a small perturbing force of solar radiation falling on the satellite surface itself can generate enough deviation in the trajectory to go out of this cube. Then beyond that, there could also be other events, like there could be loss of lock, or the satellite goes into some tumbling mode, it encounters some unforeseen forces. All that has to be actually measured and then controlled. And then our real problem was the launch vehicle through which we were going to launch was only PSLV. It has a limited capacity. You cannot carry infinite amount of fuel like what others are doing. We have a very limited amount of fuel which you can carry, which is just sufficient for you to reach Mars and reorient the satellite in the Mars orbit and reduce its velocity so that Mars captures this satellite and this satellite gets into a highly elliptical orbit. So fuel was at a premium, and any unforeseen event which results in extra fuel being spent would have resulted in we not reaching that cube of 50 kilometers. So that's how the entire process was optimized. We had to build into this satellite lot of autonomy. You can imagine that when we do our nominal satellite control, a geostationary satellite is 24/7 visible to the ground station at Hassan and Bhopal. These are the two places where we have our ground station. So 24/7 you are looking at a satellite, what it is doing, if it requires any corrective action. Whereas in this case, there would be times where for weeks together you will not be able to communicate with the satellite. You don't receive any signal from that, or you cannot send any signal to that. So during that period, the satellite has to fend for itself. If it encounters problem, it has to correct that and still survive. And when it is at the distance of the Mars, 2-degree error in its orientation is sufficient for the